Hey, this is Mr. Aiden. This is Calculus, and we're going to be going through what's called differentiation, the quotient rule. We've gone through the product rule, which did a lot of the power rule. And so the product rule was when we were multiplying two functions. Now we're going to be doing the quotient rule, which means we're going to be dividing two functions. Now, we know how to find the derivative of something like this, don't we? And how come we can find the derivative? We can simplify this by dividing each side by x, or the top values by x. And so we get 3x plus 2, and now we can do the derivative of 3x plus 2, which is equal to 3. That is really easy, isn't it? But what happens when we have something like this, sine of x over x squared? We can't divide x squared in the sine of x. And then what about like x squared over e to the x? We can't do that. And so we need a thing called the quotient rule. Okay, the quotient rule. And so to do the quotient rule, we have a function on the top and a function on the bottom. And this is how we're going to do the derivative of a quotient. We're going to take this guy on the bottom right there, and he is going to go right there, v. And we're going to take the numerator, and we're going to do the derivative of the u. So v times u prime. And then we're going to subtract. So a little bit different from the product rule in that we're subtracting on our numerator right here. And then we're going to take u times v prime. Okay, so then we're taking the derivative of the bottom guy. All over whatever v is squared. Whatever v is squared. And so that is what we call the quotient rule. The quotient rule. So I'm going to again write the quotient rule, but I'm going to write it in a different form. Okay, I'm going to write it like this. H of x is equal to, and I'm going to put f of x over g of x. Okay, so this is the same as u over v. There's nothing different, guys. It's going to be the same. But I'm just doing this kind of color coordinated so that you can see everything. We take g of x and we multiply by the derivative of the numerator, f prime of x, minus, then we're going to take f of x times g prime of x, all over the denominator squared, whatever that, I should have put him in red. I'm sorry about that. Keeping color coordinated. G of x squared right there. Okay, so let's do the derivative of this first one right here. So this is like my f of x function or my u. This is my v or my bottom function. So I'm going to take the derivative of this. So I'm going to have x squared. I don't change this v. Now I'm going to do the derivative of the numerator. So what's the derivative of sine of x is? Cosine of x. Exactly right. Minus, don't forget the minus sign. And then we have sine of x. We take that numerator, multiply by the derivative of the denominator. What's the derivative of x squared is 2x. And this is all over the denominator squared, all over x squared squared, which is x to the fourth. And again, you don't need to clean this up. You don't need to simplify it. Don't fret about doing any of those things. If you have to plug in a number, you just plug it in right now. It's really, really easy. So let's take a look at this next one. This top one's going to be my u or my f of x. This bottom one's going to be my v or my g of x. And so I'm going to take my v, which is e to the x. I'm going to multiply by the derivative of the numerator, which is 2x, minus, don't forget the minus, x squared times the derivative of the denominator, which is e to the x. Derivative of e to the x is e to the x. All over the denominator squared. So e to the x squared or e to the 2x. And so e to the 2x, which is, that's the same as e to the x squared. Okay, guys? And so let's go through another example problem. So here we go. First, we're going to take the derivative. Okay, so let's take the derivative. We're going to keep the bottom guy, right? We bring the bottom guy to the numerator. Then we do the derivative of the top guy. So what's the derivative of x squared plus 2x plus 3 is 2x plus 2. Minus, don't forget the minus, and we have x squared plus 2x plus 3. And then we got to do the derivative of the denominator. What's the derivative of x plus 4 is just 1, isn't it? All over x plus 4 squared, the denominator squared. Now we're going to plug in this 1 value. So 1 plus 4 is 5. 2 times 1 is 2 plus 2 is 4. Minus, we have 1 squared plus 2 times 1 plus 3. So that's 1 plus 2 plus 3. That's 6 times 1. All over the denominator. 1 plus 4, that's 5. 5 squared is 25. which leaves us with 20 minus 6 over 25, or 14 over 25, and I cannot reduce that, and so that is the value. Remember, with the product rule, we did one of these tables, and so I'm going to do one of these tables again. And remember, with the tables, the biggest and most important thing is do your product rule or your quotient rule and write it out. So we have g of x times f prime of x, that's a times, minus f of x times g prime of x, all over g of x squared. Okay? And I'm looking to do h prime of 3. H prime of 3. So I'll clean that up a little bit right there. H prime of 3. So I'm doing g of 3 times f prime of 3 minus f of 3 times g prime of 3 all over g of 3. Sorry. G of 3 squared. Okay, so now we go to our table. We're looking, what's g of 3? G of 3 is 2, isn't it? So that's 2. F prime of 3. What's f prime of 3? That's negative 1. Okay, minus f of 3. What's f of 3? F of 3, I'm looking for a color here. F of 3 equals 1 on our table. G prime of 3. What's g prime of 3? G prime of 3, I'm going to do that in a different color, is equal to 1. All over, so I'm going to put, right, g of 3. What was g of 3? G of 3 was equal to 2, wasn't it? So we had 2 right here, and he's being squared. And now we can simplify it, can't we? 2 times negative 1 is negative 2, minus 1, all over 4. So negative 2 minus 1 is negative 3, over 4, we get negative 3/4. And that is the quotient rule. Hope that made sense, and you'll get a little bit of practice at the quotient rule. See you guys.